Hi, everyone, and welcome to today's webinar, How Informatica Manages Secure Shell SSH Access with Time-Bound Certificates. My name is Carmen Puccio. I'm a Principal Solutions Architect here at AWS, and I'll be your speaker and moderator for today's webinar. So let's get started. So the first thing I want to talk about before I hand it over to the Aporeto Informatica team, I just want to talk a little bit about modern application development. So when we talk about modern app dev, we are essentially talking about, I like to say it's the new normal, meaning more and more companies are becoming global. And if you think about it, products are completely digital, whether it be cloud or mobile or big data. Essentially, technology has impacted application development. And you think about it, these new digital disruptions are forcing change even faster. This new normal means that applicators essentially have to insert this, I like to say it's a digital DNA into their culture, their processes and technologies to transform into top performing organizations. So with that, you need to have this need for rapid innovation. And you've probably seen this slide many times here. We like it at AWS. We're essentially saying this is our innovation flywheel. And in order to innovate as rapidly as possible and stay competitive, we start talking about modernization. And these days, modernizing your business applications, it's an inevitable aspect of doing business. Businesses want to drive growth. They want to accelerate their migrations with repeatable processes and patterns, all while maximizing the value as they modernize their applications. So you think about it, it's really about the speed and agility for that digital business, in that the faster they collect and analyze feedback, the quicker they react to their customers. And the more they can reduce costs, the more they can experiment on new ideas. Maybe the faster they get these ideas to market, the more successful they're going to be. So what does it look like in real life? And so what are some options for modernizing an application? I always like to say, let's start talking about containers, right? So when it comes to how customers can accelerate application delivery while reducing costs, common approach is to leverage containers. I work with the AWS Container Partner team here, and I love the container story because it's really compelling because it allows customers to be effective and agile, and containers provide an option to deliver applications more quickly for development and operations teams who are under pressure to adapt to growing business needs. Businesses know that getting software products and services to market, it translates into faster or gained market share. And using containers can help enterprises modernize legacy applications and create cloud native applications that are both scalable and agile. So, container frameworks such as Docker provide a standardized way of packaging applications, all the code, the runtime, the libraries, and you're going to run those across your entire software development lifecycle, regardless of the environment. And when you talk about the benefits of containers and why customers are adopting them and why enterprises are adopting them, the first one is, like I said before, it's defined as code. So your containers package your code with the configuration files and all the dependencies it needs to run consistently in any environment. This is a great starting point to start talking about microservices as well. They provide this isolation that makes it easy to break apart and run applications as these independent components called microservices. Modern applications are shifting to cloud native, and microservices architectures and containers are a perfect way to encapsulate these small pieces into really small portable units. They help facilitate automated testing and development. So your development methodologies are changing with developers shifting to agile methods, DevOps, and leveraging CI/CD systems. Containers being this lightweight portable mechanism, they're essentially like a great vessel to wrap code in to push them through these new software pipelines. Monitoring. Containers provide isolation that lets you granularly set CPU and memory utilization for better use of compute resources. And with that said, it's very important to think about your application monitoring as well and how you ensure the overall health of your application as these containers are going up and down in a dynamic environment. And lastly, but not least, is the security and compliance controls. Because, again, they help enforce that mindset of infrastructure as code in your app lifecycle. You need to think about the security and the benefits that come along with it. So you have the ability to set and version not just the container itself, but all of the packages that make up your application. And if you combine this with processes like vulnerability scans of the container images and incorporating automated checks into your CI/CD workflow, your security and developers, your security teams and your developers can work to ensure a high level of security for that containerized application. when it comes to our customers like they love AWS container services because it not only provides the broadest set of capabilities to run their containerized applications, but it's also an easy place for them to run their containers. The services are deeply integrated into the AWS cloud, so you're getting all the benefits of things like IAM security, VPC networking, load balancing, all while enabling your DevOps teams to work with our developer tools. So container management tools can be broken into the three categories of registry, orchestration, and compute. And AWS offers services that gives you a secure place to store and manage your container images, orchestration that manages when and where your containers will run, and flexible compute engines to power your containers. AWS helps you manage your containers and deployments for you, so you don't need to worry about the underlying infrastructure. And no matter what you're building, AWS makes it easy and efficient to build with containers. We've probably seen monolith versus microservices comparisons before, but I just want to touch on it really quick. Customers have been trying to figure out how to migrate off their monolithic architectures and have naturally looked to microservices. And one of the reasons they're doing this is to essentially eliminate that friction that comes with maintaining a monolith through the software development lifecycle. They typically have many developers all pushing changes, and if they're lucky, they might have a software delivery pipeline, but regardless, it's shared, and they need to coordinate their changes with other developers and engineers to make sure that changes won't break someone else's code. Shared libraries are also commonplace, and if you want to upgrade a shared library to take advantage of a new feature, you have to convince everyone else to upgrade at the same time, which is difficult. It's really important to fix or patch, and you now need to merge in everyone else's code in the monolith to go through the process of compiling and resolving conflicts. You need to then rebuild the app, run all the test suites, and then you're starting that deployment process to staging and production. So even a small change sends you through this process that doesn't lend itself to quicker to market concept that I was talking about before. It's really unacceptable if you really think about today's technology landscape and what's available. So it's a leftover artifact in my mind of the legacy development cultures. And this is why people talk about microservices, because again, it's this small unit that does one thing. It's an independent deployment. It scales independently, and it's just a great vessel to take advantage of containerized workloads. Monitoring is something that I love to talk about as well when it comes to the container, experience, and it's really at its highest level. You're thinking about it at maintaining the reliability, availability, and performance of that modernized app, and you need to collect all the data from all parts of your application to make sure that you can easily debug a multi-point failure if one occurs. So before you start monitoring your application, you really need to think about your monitoring plan, answering questions like maybe what are my monitoring goals? How often am I going to monitor these resources? What tools am I going to use? Who should be get notified if something goes wrong? And again, if you think about it in the context of microservices, this is where you're really going to think about distributed tracing as well. You really want to have visibility of the end-to-end workflow of your application, because again, it's not just that single monolith anymore. You want to see these calls essentially traverse through your system. Maybe it's something like where AWS X-Ray comes in, because it's really handy to give you that end-to-end view of requests as they travel through your application, and essentially maps out a flow using a correlation ID in your event chain. And again, I've touched on CI/CD before. You really can't do this without the concept of a CI/CD pipeline. And again, people are doing this, and customers are incorporating CI/CD and DevOps practices in their application lifecycle. But because by incorporating automation and that cultural component of learning how to integrate frequently, they're able to address bugs quicker, improve software quality, and reduce the time it takes to validate and release these new software updates. And lastly, before I hand it over to the Aporeto team, I just want to touch on security, because I know you're here today to learn a little bit about security. So if you think about security and compliance across the entire app lifecycle, it really comes down to the things that you need to think about to secure your application, but also how you can incorporate automation and detection throughout the deployment process to address blind spots without slowing down the innovation that we were talking about earlier. We always say security is paramount in any organization, and you need to think about all the attack areas of a microservices-based architecture and how you will protect and audit around them. So maybe it's the security scanning that I was talking about before, essentially understanding what's running inside your environment, what packages you have installed in your container images. And the other one that I want to just mention as well is incident response. And if you think about the application lifecycle, how are you going to establish control, determine impact, recover as needed, investigate root cause, and improve, right? So you really have to realize the importance of monitoring and metrics when tied to security and incident response, especially when you're at scale with microservices. You have to realize the importance of having that response plan and know that your teams know what to do when something goes potentially wrong. And obviously having them follow procedural steps is a path towards error because they may miss a step. And this is why you want to look into automating the mundane and have the automated redeployment mechanisms to learn and improve from your process. And finally, organizations obviously want to test their tooling and incident response. I typically like to see customers do things like game days or security simulations. So incident response game days are exercises that allow security teams to practice, essentially how they would respond should an incident occur. So again, these are just some of the things that you need to think about when you're thinking about microservices as a whole, and especially that security context. But with that said, I don't want to take any time away from the Aporeto team and Informatica. So with that said, I'm going to pass it off to Arful Huck, and I'll let him talk a little bit about Aporeto.
Thank you, Carmen. Hi, my name is Arful Huck. I lead product management here at Aporeto. So I'm going to do a quick introduction of Aporeto, who we are, and I'm going to hand it off to Alec. So just a quick introduction of Aporeto. Company's been around for close to 4 years now. We're a venture-funded company here in the Valley. What we offer is a zero trust security solution through our cloud platform. Our cloud platform is also SOC 2 compliant. We've been adopted by Fortune 50 and Fortune 500 companies, and we're also available through the AWS marketplace. We're an APN partner, so there's a number of ways you can consume us if you're a part of the AWS ecosystem. All right, so what I'm actually going to talk about is managing cloud infrastructure, and that's really where Alec is going to come in and talk about the challenges and how he went about solving that problem. But to introduce some of these things, and actually to kind of tie back to what Carmen was talking about, Carmen talked about cloud containerization and microservices. It's really enabling your business to move fast. Moving to cloud infrastructure is you're moving to dynamic infrastructure in the cloud, you're consuming cloud native services. How to manage this infrastructure requires automation and DevOps. And Carmen mentioned that that's the only way to kind of scale as you move to cloud and be able to consume all of that that cloud has to offer. So what we're going to talk about in the next, what I'm actually going to talk about in the next is, as you're making the shift, the existing security practices and workflows that you have that may be applicable in your private data center it may not be very applicable in a public cloud infrastructure. And in a public cloud infrastructure, you have sensitive data, and so what we're going to talk about is how you're protecting access to the cloud infrastructure. All right, so to address some of the challenges, the first one I'm going to talk about is keys. Because whenever you need to access cloud infrastructure, whether, for instance, you're trying to do secure shell access into a cloud VM, and Alec will talk about that, or even trying to get access to cloud resources, what you typically use is a key. And it so happens that keys are a big threat vector now. So being able to protect these keys is an important aspect. For instance, the 2019 Verizon data breach report states that 30% of breaches that are happening in the cloud are happening as a result of stolen or misused credentials. If you've kind of tracked the market, the recent Imperva attack, as well as the infamous Capital One attack, these were all attacks as a result of misuse of static keys, right? So that's an important threat vector and challenge that customers have to face. Now, keys are not new. We've been using keys even not just in public cloud infrastructure. So there have been solutions out there, traditional key management solutions out there that you've used in a private cloud environment. And a lot of these traditional solutions, the workflows and how they were built wasn't built for modern cloud native infrastructure. So when you have a very dynamic infrastructure, it's very complex and error prone to use existing solutions, right? And lastly, shared accounts. So when you log into an AWS EC2 instance, for instance, and I'll give you an example here. For instance, it's Carmen, RF, myself, and Alec logging into an EC2 instance. And you're using a shared account. So everybody logs in as EC2 user. Now, RF performs some unauthorized activity on this VM, but it's not very visible to your security team. You really don't know what happened on this VM. Was it specifically RF? Was it Carmen that issued specific commands? Did he get access to an unauthorized key on that VM and potentially use this key to get access to unauthorized data? And if you have sensitive data in these environments, you're bound to compliance issues and being able to kind of do forensics to figure out what potentially happened in these types of scenarios. So these are some of the challenges that we see customers face with traditional key management solutions out there, and what are some of the threat vectors. So with Aporeto, what we're doing is modern identity for secure access to infrastructure. So we talked about static keys. Getting rid of credential management is number one. So essentially being able to move towards single sign-on capabilities, right? So anytime you log into a virtual machine, move through a single sign-on process. And I'm actually going to demonstrate this to you as part of our demo towards the end of the deck. This is designed for elastic cloud infrastructure, and the workflows that are incorporated into such a solution are meant for dynamic cloud infrastructure. You're not having to go in and do things like check out a key and being able to use that key to access cloud infrastructure, right? So this is, again, something that we will demonstrate. The solution is tied into a corporate identity provider. For instance, you could be using Okta, ping Auth0, and the identity of the user now enables you to control what that user has access to. The user logging into a VM, for instance, RF belongs to group developer, and should he have access to this VM, right? And the lifecycle management of the access now ties back to the corporate identity. For easy compliance, being able to monitor all activity on that VM, understand if specific commands were issued, who issued these commands. Even though RF logs in as EC2 user on a VM, was specifically RF that issued a specific set of commands. Getting that level of visibility is very important for compliance. And then reducing risk of unauthorized access, for instance, for lateral movement. So I have access to VM, and then from there, what could I potentially do within this environment? Could I potentially get access to a database or SCP data out of this VM? And you want to be able to prevent those sorts of things. That's part of our solution. So all of this is offered through the Aporeto cloud platform. And with that introduction of what we do at Aporeto, I'm actually going to hand it off to Alec. Informatica is one of our first customers, and it's been great partnering with Alec at Informatica to kind of build out some of the things that we just talked about. So Alec, off to you.
Thank you, Arthur. So good morning, everybody. And I'm here to kind of talk about how Informatica implemented our secure time-based access using the Aporeto PAM. So Informatica, as many of you know, has been around for a while. We're essentially a company that lets you organize anything that you need to do in your data. Initially, we were kind of known for just transforming data, but we have a lot of vertical markets now, and we are top right quadrant for a lot of verticals. We're based on a microservices architecture, and we initially moved from a legacy monolithic platform, which was described earlier. So that's kind of the transition we're in. We have, let me move on to the next slide. So we have a fleet of about 10,000 VMs. We're transitioning to containers. We're actually a layered system. So I'm actually in charge of the infrastructure portion, which is the lower end. And then on top of that, there's a platform. And then on top of that, run the applications. So the infrastructure side is already containerized, and we're actually then moving all the other layers into being the same process. So the challenges that we actually have is obviously there are many security steps to actually hardening images in the cloud. So one of those that we actually have, one of the issues that we have are things like key rotation, as again was mentioned earlier. So it's very easy to issue a key. It's very hard to rotate it, especially when you've got a fleet of 10K servers, and we actually envisage that number going up by about 5 to 6 times. So we'll be in about the 60,000 range, probably by the end of 2020. And then the other thing is things like service-to-service ACLs. So we're talking security groups, we're talking ingress and egress rules here as well. Those are all, let's just say, not very easy when you actually get to orders of magnitude of scale. Okay, so one of the big requirements that we have is that whatever we chose had to be able to work on VMs and containers. And the reason for this is that some of the internal systems are actually harder to convert to containers. Again, think monolithic to microservice. And again, some of them are actually just lower priority, and they're lower risk, so they don't necessarily need the agility of microservices. So we'll get to them eventually. But again, whatever we chose had to work with both. So I need to be able to get at both types of instance and also bake those instances essentially using the same pipeline. The other thing about running everything within a pipeline is that this takes care of all the integration and compatibility issues. So essentially what that means is that when the application starts running on one of my images, then it shouldn't really care, because all of these things are already taken care of by testing within the pipeline. We have very, very strict compliance controls. So we're SOC 2, we're doing other things like GovCloud, FedRAMP. And the one thing that we see as the biggest risk is humans. So obviously from a DevOps perspective, we're trying to automate everything, and humans are not versionable. We can't version a DevOps engineer and require him to follow a specific process. They typically don't follow the process to the letter, again. So people miss steps, even if it's documented or it's automated. The way that we see it is, as soon as a human touches the system, it should be considered polluted. And essentially everything there has to be audited. So whenever a human does anything, we want to be able to follow that. And as Arifel mentioned, typically if you're using a shared user, it's really hard to track them down. And the way we did it before, we basically use a DHCP address. We'd go find the VPN login, trace that back to Okta, which was the corporate identity. And it was a tracing across many, many systems to try and even figure out who was logged in. And then once they've logged in, you had to figure out what they were doing. And if 2 people were logged in, then it became kind of tricky. So again, what I needed was some way of actually saying, okay, it was this person who did this. So again, that was one of my requirements. And then the other thing was time-based access. So our old key method, we did rotate keys every 30 days. Everybody got their own key. Inevitably, however, people tended to leave keys lying about, especially if they were hopping through the system. Go to a jump host, log into one system, then copy their key there, then log into another one, and then they essentially forget to remove it on the way back. So we had to put in systems that would go and track these things down and remove them, and potentially go and tell the user not to do that type of thing. The last thing I'm going to mention is the 5 nines requirement. And again, because systems are, again, incident management was mentioned before. 2 years ago, we typically had a lot of incidents. Today, we have very few incidents. And this is more based on the way that we're actually moving the resilience needle within the company. So where we do expect engineers to actually have to log into systems and actually debug in situ, we're actually not expecting that to be the standard methodology going forward. We're kind of moving more towards telemetry, so that the actual automated systems typically take over. So the 5x9s, even though it's a requirement, is not really a requirement. I actually consider 3 nines enough for this. The way I see it is, if somebody's SSHing into a system, polluting it, we kind of need to now remove that from the system and actually figure out why they had to log in the first place. How did that ever make it to production? Okay, so the steps. So obviously we're secure by design. All of our engineers go through probably about 2 weeks of training every year to go over application design and security. And the whole point of security is it's not a bolt-on thing afterwards. Everybody has to kind of think about how and when security is implemented. And the way that we look at it is that we try to iterate to make things more secure, but we focus on transparency, and so that an application doesn't necessarily have to think about the security from a infrastructure's perspective, but it should always behave as it did. And if anything, it should just become easier and more transparent. So we actually used Okta as our identity provider. And Okta actually allows us to follow the identity through the entire system. So this actually allows us to create much better ACLs throughout the system. We can say, user 1 can do this on this machine and not on that machine. We couldn't really do that before, or it was really, really hard. And then the other thing that we actually did was introduce the concept of every session. So what I mean by that is, from a key perspective, somebody had key for a month, and then they knew after a month they would go away. Now they have to get a certificate every session, and that session may last, let's say anywhere between 1 hour and 4 hours, and then after that they have to go and get another certificate. That introduces a concept within the minds of everybody that they can't just log in everywhere. They have to follow the process, and it's a case of, yes, you can have access to everything. In fact, we'll give you more access, but we are going to follow you. Big Brother is watching. And it actually does allow me to introduce the concept of keyless going forwards. So at some point in the future, we would actually like to introduce a concept of completely keyless. And I maybe speak about that a little there. But obviously, the important thing for us here was that we actually delegated this external trust to Aporeto. So we actually did look at this ourselves. We spent about 6 months trying to figure it out, and I kind of decided that this was a very hard resource to do. So I'm going to step on to the next slide, actually. So the decision was kind of based on a build versus buy. So if I was to do this myself, it would cost me many engineers, and it would be quite a high initial cost just in time and maintenance. So in terms of the build versus buy, it was a very easy decision. So, and again, from a DevOps perspective, everything is tag and namespace based. So this model actually allows us to easily integrate across all of our infrastructure by just adhering to standards. As long as people utilize the standard naming conventions and standard tagging procedures, just describing different services to different service owners becomes really easy. So everybody understands the standard naming conventions, and then they understand the security models that follow those conventions. So it makes actually communication across services much easier. It's really hard to put that into words. We have 42 different practices within just one of our platforms, and each one of those 42 different teams kind of speaks a different language. So this allows them to speak a common language. And again, obviously, all of this simplifies things like scaling, high availability, resilience, all of that stuff. So, and we're looking at creating a self-service model for discovery and policy engines. And again, those two actually came with Aporeto, so they were essentially free for me. So they were other wins. So the policy engine, I was looking at things like RepoKit, and service discovery, I was looking at console. We still use service discovery, but not to the extent that we were going to, because this simply allows us to do it via a namespace model. And I don't necessarily need to query, I just need to do algorithmic calculations on namespaces. And the last thing is, we're actually heavily invested in two-factor authentication. We use Okta as our provider. Okta is very good at what it does. We didn't want another provider. So this actually moves us towards the reduction or elimination of users' accounts as well. So again, as I mentioned, when a human touches a system, we consider it polluted. So eventually we want all of the accounts that touch the cloud to only be service accounts. However, until that happens, I need to know who, and I need to know what and why and where and when. So again, Okta is our way of finding that out. Okay, Aporeto's approach. So just in time, when a user goes to a web page, they present their SSH key, and they're given a certificate, and that certificate allows them to SSH to whatever they have access to for a specific amount of time. They don't necessarily now need to go to a wiki page to figure out what the jump post is or what the route is to everywhere. They can just go to wherever they need to, and assuming that the ACL is there, they can get there. If it's not, it tells them that they don't have access. So the huge win for me here is this no more shared keys or key rotation. I no longer have to go searching for shared keys that are searched around. So I consider security a pre, a run, and a post. So there's no such thing as being 100% safe. Anybody who tells you there is probably not telling you the truth. So the pre section is the build pipeline. This is your, harden the image. This is the scan the image, the run a bunch of testing against it. The run is the, okay, now I need to have security groups in place. I need to have my network access in place. It's egress detection rules, it's things like that. And the post is, oh, okay, I've been breached. Now the numbers for me there are like 99.9 for the pre, 0.1 for the run, and the hope, really hope you can catch that moving target of the 0.1%, because it's a constantly moving target. So I don't want to catch things at runtime. I want to catch them in pre-runtime. But this just in time now gives me the ability to kind of reduce the impact, because I no longer have shared keys kicking around that people can pick up and just log in. Now I know for a 4-hour period that's associated with a change request that somebody's doing something, and I can track it. And obviously from an auditability perspective, this is kind of critical to me. So now when we come to doing our certification and someone says, well, show me what was associated with that CR, I just go back and show the audit report, and everything that happened is right there. Okay, so as I mentioned earlier, initially we kind of looked at the network side and implementing this ourselves just by using the Aporeto network solution. Essentially using service-to-service lockdown through MTLS and tagging. But we had two other concerns, and those other concerns were SSH and token. SSH I've already explained. Token again was kind of another free win for us. It allows us to go back 20 years. I know that sounds odd, but 20 years ago, if I was on a network and I could see a database, I could connect to it. This actually now allows me to do the same thing from an application perspective. So now I can actually use Aporeto to keylessly access Vault to fetch a key to access a database with client auth and get the specific keys via ACLs. And only that application has access to that specific portion of Vault. So from an applications perspective, it's the same as it was 20 years ago. They just access the database and everything underneath is transparently done for them. So again, another free win. The other thing I was trying to do as well was create a policy engine. And again, I looked at other tools for this. However, this one came free. So now I have the ability to create and distribute security policies, which are taken care of actually by our security team. So I provide the methodology and the methods for getting those around, and the security team creates and applies the policies. Okay, our benefits. So obviously, after we have a number of things that we see from a pure numbers perspective, but it's kind of the hidden ones that are important. So the biggest one really is that we became a more dynamic service. So again, 2 years ago, we would typically have several QA environments and several production environments, and they were relatively static. People didn't want to change them, and it was typically patch in place. And well, again, we all know what happens with those things. They typically stagnate. So now we're actually able to spin up and throw away environments, which is obviously the better model. So this allows us to actually consume far more resource, a much more optimal cost, if that makes sense, because the fixed systems typically stood idle, and the utilization was actually in the low sub-teens. So if I could get a system to 10% utilization, I was happy. Now I'm kind of looking to the 20, 30%, and ideally I want to get to about 60% once we move to containers. So I now have the ability to do dynamic resource, horizontal scaling, and actually have much higher utilization. So this essentially paid for itself simply by not consuming as much and consuming more of the services more dynamically. Things like reduced deployment times. Obviously, with the throwaway methodology, I don't need to kind of test for things not being there, and patch in place is roll back the typical switch of a directory. So now I just deploy new and I canary it in, and if it's good, I I kind of ramp up the traffic to those systems, and then eventually I'll throw away the old system. So this actually allows me to do very quick deployments with canaries and rollback. So again, another win that kind of wasn't there a couple of years ago. The one thing that this kind of does imply, though, is that I actually have to have a much more robust pipeline testing program, which again, I can do now because I have a far more dynamic environment and I consume a lot more services. So we actually do build pipelines we use Kubernetes, so EKS, and we actually spin up these, what we call them mini pods, where we actually do testing, throw them away, spin up another mini pod, do the next test, throw that away. So I can actually have far more unique tests because I can have as many of them as I like, whereas in the previous generation, I had 6 environments, and one of those environments may already be tied up. In fact, they all may be tied up. And all of these all the other, obviously, security enhancements that come along with Aporeto. So the networking, which we initially looked at, we haven't really implemented yet, but it does give us a huge visibility into service dependency. And I know that a lot of other applications do this, but again, this is just kind of free with the product. In the future, we're actually going to start implementing service-to-service MTLS at the either Aporeto level or the service level. But the whole point of the networking is I can now say that I can actually create a flat /16 and say this service can only talk to this service. So even with MTLS, I'm also securing it at the network layer so that I've kind of got 3 layers of security. I've got the network. Yeah, this service can only speak to this one. I have the MTLS, and I have a client authentication as well. So this gives me really, really good control, a very good granular control. Okay, so the next steps that we have, we're obviously iterating on this. We've been at this for about 3 years now. Aporeto's been in the picture about 2. Our goal is obviously a customer happiness. We want the customers to be as happy and productive as possible. This means making everything more resilient and obviously making the user experience for the customer the best thing that can possibly happen. So we obviously need to make sure that our controls become more automated, our policy-based controls become more, how do I put this, algorithmically controllable. And obviously, actually, one of the new benefits that we'll get from Aporeto in the future is to actually apply security groups at the Amazon level using the tagging procedure in Aporeto. So if I say service A can speak to service B, they'll just create security groups for me and we can apply them. So the actual IT compliance, which is different from the cloud compliance, become happy as well. And it just satisfies another control. And I think with that, I'm handing back to Arful. Obviously, any questions, please let me know.
Okay, thank you, Alec. All right, so this is Arful back. So what we're going to show you is a quick demonstration of the Aporeto product. And before I start the demonstration, this is recorded. Before I start it, I'm just going to give you some context on what we're actually about to show you. So on the left side here is actually a user that is going to log into an unprotected VM, unprotected from Aporeto, and we're going to log in using your static credentials, and we'll show you sort of the things that can happen in these sorts of environments, what sort of privileged access you could potentially access to. And then on the right-hand side, you see a dev and a prod user, and for these dev and prod users, what we're going to do is log in through Okta, actually. So we're going to do a single sign-on with Okta and then use an ephemeral cert, as Alec mentioned, to log into these VMs. And it will be actually one VM. You'll see 2 users log into the same VM and then be able to control what that user is capable of doing based on user identity. So with that background, I'm going to start the demo. All right. So in this first part of the demo, I'm logging in using a specific credential that's stored here in this directory, and I'm logging in as EC2 user into a VM. So I'm logged in now, and I'm going to issue a set of commands. For instance, I can sudo if I want. So I have sudo privileges. I have no controls on that. I can potentially go out to the internet. Here I'm going out to google.com. And this VM potentially has an application needs access to S3. So as a user, when I log into this VM, I can now potentially start to list what things are there in S3. So, just for the kicks, I have a keto cake recipe here, and oops, I have a top secret Coca-Cola recipe that I have access to, and you don't want your users to have access to this sorts of information, right? But as a VM, I've given it the privileges and it's able to access those sorts of things. And what I've just done is copied over that specific sensitive data, and I'm able to actually exfiltrate this data because I have outbound access to another host machine, right? So those are potential issues that you can face in your environment. And lastly, I'm able to curl to the local metadata API available to me on this EC2 instance and get access to an SDS token. And I can use this token to now potentially get access to and other sorts of things within the environment. So now what I'm doing is actually I'm going to show you as a dev. I'm through Okta. So just what happened, the Okta login popped up. I logged in through Okta. And using my Okta credential, I'm able to access this VM. And I'm logged in as a dev user. And as you can see, I tried to sudo and I'm not able to sudo, right? I'm going to try and go to google.com to show outbound access. And I'm actually preventing outbound access just based on this user, right? What this user is capable of doing. And then next, I'm going to issue a set of commands to get access or list what's in an S3 bucket, because potentially this VM needs access to that S3 bucket, and I'm not able to get access to anything. That I've restricted this user completely so that they don't have access to any S3 information. And lastly, I will potentially try to get access to a token, and I'm not even able to get access to a token. So think about this even from the point of view of containers. You have multiple containers in a single VM. These containers need access to a specific IAM credential. But as a user, when I log into this VM, I should not have access to the IAM credential. And lastly, I tried to connect to a database that's in the same VPC. I have connectivity to this database, but I shouldn't be allowed to connect to that database. So I was denied, right? And now what I'm doing is I'm going to log in as a prod user, again using Okta, and I'm going to log in to that same VM that I just logged in, right? I'm going to log into the same VM that we were just looking at just now, and I'm going to issue the same set of commands. And now, based on my user credential, who I logged in as with Okta and the claims that Okta provided, I'm able to authorize this specific user to get sudo access, to potentially get outbound access to the internet, if so required, right? And again, I can granularly control, even for instance, what S3 information this specific user has access to. For instance, this specific user cannot access the top secret information. Potentially the keto cake recipe is okay for this user to access, right? And lastly, I'm going to try and connect to a database that's in the same VPC, and I'm able to do that because as a prod user, I've given this user that, hey, you can laterally connect from this VM to something else. And now what I'm showing you is our cloud platform. This gives you the single pane of glass, the visibility, the audit, logging, and compliance that you need for user activity on your VMs. So I logged in as a user. I'll tell you all the information around the session activity, which user logged in as what, and what sort of activity that user performed on that VM. And here is kind of a visual representation of that as well, like what this user was able to get access to. So with that concludes the demo. And so just to recap, what we showed you was based on a login mechanism using Okta. I'm able to single sign on with Okta. Based on the identity of that user, I was able to control exactly what that user was able to do. Log in once you log into the VM, I'm able to get access to get SU into the VM, or potentially get access to a cloud credential. All those sorts of things are things that you can control based on user identity. This solution is available through the AWS Marketplace. We have a free trial. Please come over to aporeto.com to learn more. Obviously, go to Informatica as well and learn about what Informatica is doing. With that, that concludes the presentation, and we're going to move into the Q&A section.
Awesome. So thank you, Arful and Alec. So like Arful just said, we're going to transition into live Q&A. As a reminder, you'll be able to submit any written questions through the questions panel. So please do so now. We do have a couple of questions in there already, so I'm just going to start, throwing them out there. And again, this one, Arful, Alec, maybe you both want to chime in a little bit, but if you're talking about removing SSH from the environment, like maybe you could talk about the benefits of time-limited SSH and how does that level of access help a customer?
Yeah, I'll take that one. So in terms of SSH, it's never actually going to go away. So even when you actually get to containers, you still have node level, and somehow you will actually. I don't see the SSH ever going away. Now that actually tells you something about the telemetry of the system. So as long as SSH is available, that means that the telemetry and potentially the distributed tracing and potentially the monitoring and the alerting and the incident response needs to be visiting. So you have to iterate through that. Now, maybe in 5 years, maybe in 10 years, I'll be wrong. Maybe SSH will go away, but for the foreseeable future, we have to do it, and we have to make it so that it is workable within the auditability and security framework. So it's not going away. It just needs to be made less of a primary tool, if that makes sense. So, Arthur, do you want to have a go at that one?
No, I think you addressed it very well. I mean, SSH access is going to be something that we see customers will need for some time. It's a question of when you need SSH access, who has access to what part of your infrastructure, and as you correctly highlighted, what this user does when they're logged into this VM, being able to get the auditability and login. Yep.
Another one in there that folks seem to be curious about was the adoption of EKS in the environment. And, I don't want to necessarily pose it as challenges, but maybe you could talk a little bit about some of the things that you encountered that you had to take a step back and think about as part of your adoption of EKS.
So again, I can take that one. So one of the things, there's a couple of things, obviously. So it is a learning curve. Again, in my experience, the pool of people who actually understand Kubernetes and actually understand it at the cloud level is nowhere near as big as the pool of people who understand standard VMs. So the actual learning curve of deploying a service using Helm, using any other things within Kubernetes is smaller. So that's obviously one of the challenges, is either finding or training these resources. And the other thing, the kind of major challenge that we had, but believe it or not, was once you're actually within the cluster, then when we initially started, the IAM rules didn't apply. So essentially any container/service within a Kubernetes cluster could speak anywhere else. But I know that's not the case now, but that was one of the challenges we faced, because now we had lateral traversal within a cluster. And obviously, again, Aporeto did solve this, and Amazon actually have a solution for this now. But again, that was one of the challenges. Remember, we started this journey about 2 years ago. And then obviously the other mindset is going down the immutability, the auto configuration. So that change, so the standard CM model, you really have to throw it out the window, and you have to be very thoughtful about how you get engineers to actually say, okay, I'm okay with this being immutable. I understand my dependencies. I understand how to do auto configuration. So those are kind of the challenges that we faced. And I think it's something that probably everybody goes through.
Yeah. So another one that's popped in, and Arful, maybe you could talk a little bit about the licensing model and procurement of Aporeto.
Yeah, absolutely. So the way we license the solution is it's per node licensing, or per VM, per OS instance. So the number of instances you have is what we pay, price it based on. It's a cloud delivered solution, so obviously the service is something that you have access to. So everything that I showed you in terms, all of that comes as part of the solution, and you just pay on a per node basis.
And folks are curious about essentially the, it's securing all of your SSH sections. But if you think about, a single point of security failure, would that potentially introduce a single point of failure inside the environment? How do you usually handle that from the objection handling side?
Yeah, good question. So what we have actually done with our our solution is we've made it available across multiple cloud regions. So our SaaS platform in itself is something that's deployed across multiple cloud regions for geo redundancy, just to ensure that, hey, if there is a failure or something of that nature, connectivity issue to a specific cloud region or specific data center or availability zone within a cloud region, we're available across multiple cloud regions. That's one. And obviously, when you do make this, when you do a, you can potentially have a backup as well, which can be a certificate or something of that nature to authorize locally. So that's obviously one mechanism, and not everybody has to have that specific certificate or key. It can be specific individuals, but that's, you know, it's the same kind of question that goes to even using Okta. Okta is a SaaS delivered identity solution, and so when Okta is not available, you have the same problem. But yeah, so we face the same challenges, and we've built a highly redundant solution that kind of mitigates those problems.
Cool. And I think we have time for one more, and maybe this one's for you, Alec. But you know, maybe you could talk a little bit about the integration of a traditional CM tool and how you essentially got all of that to work with EKS.
Good question. So again, this comes down to the auto configuration portion. So typical CM tools, you would actually kind of do it all at once. So you would actually use Chef, Puppet, Ansible, you know, Salt, whatever, and you would essentially create a VM, spin it up. You would actually provision it in situ, and then potentially even configure it in situ. So we literally had to throw the configuration portion away. The configuration part we were able to keep, so we could still use the configuration side to provision our images, and that works for containers and for VMs. However, once it gets to the, I'm now instantiating my image, that's where I have to do auto configuration. So we moved that portion from a CM tool. It doesn't really work, especially when you get to containers. Now, I know that some people will argue with me with that, but in terms of ease of use and transparency, we actually ended up moving to auto configuration through console template. And that actually really accelerated the deployment. So the actual deployment side of a typical CM tool, it hits a vertical ceiling, whereas the auto configuration doesn't. So I can scale horizontally in the 10Ks, the 10,000s, whereas a CM tool kind of limited me. And that's kind of how we did it.
Awesome. So with that said, I just want to thank Alec and Arful one more time, and thanks to the folks who attended, and I'll talk to you later. Take care.